Unit 2, Part 1. Unit 2, we explored polynomials and identities and synthetic and long division, all of these things. We really explored what to do with these polynomials, all right? So let's just go over it real quick. Adding, subtracting, and multiplying polynomials, both formal, f of x plus g of x, and informal, 2x plus y. And then we divided polynomials, long division, synthetic division. When do we use the appropriate one? And then function composition came last. Okay, there were other subtopics sprinkled in there. I'm going to try to get to them. If not, just go through your packet, go look at it, and see what I missed. All right, most of it, I'm hitting the highlights. So let's get started. Adding and subtracting first. If you look over on the box on the left, okay, we're giving you a set of parentheses. All right, and we're giving you a plus sign in between those parentheses. You need to make sure you understand the difference between a plus and a minus sign. All right, if it's a plus sign, all you got to do is highlight or underline, box, whatever you need to do, give you that visual, and combine like terms. 3x squared plus 8x squared gives you 11x squared. That is where they got that first term. 5x minus 3x, that gives you a 2x. And then negative 10 plus 2 gives you negative 8. All right, it's pretty straightforward. Now, the second part is when you have a minus sign in between those parentheses. You need to make sure you distribute that minus into all of those terms. If you recall the last videos, I had struggles with it. Signs are very difficult. So the key is to take your time and to triple check your work, okay? So they rewrote it, 5x squared minus 4x plus 6 minus 4x squared minus 4x minus 6, all right? So far, so good. If you notice, you have a plus 6 and a minus 6. That cancels out. I apologize. That cancels out. This becomes 0. So your constant goes away. The number by itself, there's no x there, there's nothing. That constant number goes away, leaving you with just an x squared term minus 8x, all right? Please use a highlighter. Please use whatever methods you need to make sure you don't miss those questions, all right? Very good. The box to the right, multiplying, okay? Here is an example. You guys, we've been doing this multiplication for a very long time. It is what it is. You can multiply a binomial times a binomial. I have faith that you've learned this, that you've lived and breathed this. The only thing that you might not be able to do when multiplying, and just as a recall, I'm sure you can do it, is when you have a binomial, x, let's say x minus 3, times a trinomial, x squared minus 2x plus 6. I just made that up. I don't know. But this is the example. We told you to draw an area model, okay? And the easiest way to do this is if you have the x and minus 3 here, and then separate these boxes to draw 2 lines, so we have 3 spaces, and put your trinomial up here, x squared minus 2x and 6. Now we just multiply. This becomes an x cubed minus 2x squared, 6x. Now we go ahead and multiply this. A negative 3x squared minus, times a minus is a positive. So positive 6x, and then a negative 3 times 6 is a negative 18. Now, if you were in my class or whoever class, they may have told you that those terms will match and those terms will match. So you can combine like terms, and you will get x cubed, a negative 3x squared minus 2x squared gives you a minus 5x squared. A 6x plus 6x, well, 12x. And then last but not least, minus 18. And that is a binomial times a trinomial. If you have questions, please ask. All right. What happens if they give you formal function notation? okay? So what I mean is this. You follow the same rules you'd use to add, subtract, okay? And sometimes what will happen is they'll give you a number. So let's go ahead and just get started with an example. This would be an example. If I give you f of x is equal to 2x plus 3, and then g of x is equal to 3x squared minus 6x plus 3. It's two different functions, all using function notation. All right. Part A will tell you f of x plus g of x. Okay. And then what will happen is there could be something that says this. Okay. F plus g. It's the same thing, you guys. It's just written differently, and they're going to give you a number. Okay. F plus g of 2. You use your rules for evaluating. So let's get started. If I'm simply adding them first, you would combine like terms, okay? So if you need to, put it in parentheses and set it up like you've seen before. 2x plus 3 plus 3x squared minus 6x plus 3. This will simplify down to 3x squared minus 4x plus 6. And that is f of x plus g of x. Now, I told you this is the same thing. It's just written with it both in parentheses. It's okay. All of this is very fluid. You have to understand there's multiple things that represent the same exact thing. And that's okay. Don't be afraid. Use logic. I have faith in you, okay? I really do. So, what is the easiest? The easiest is to go ahead and take this solution that you just found and simply plug in 2 for x. Why? Because guess what's supposed to be there? An x. And since they gave you a value, all you got to do is plug it in. Substitute that value in. So we're going to have 3 times 2 squared minus 4 times 2 plus 6. Well, 2 squared is 4 times 3 is 12 minus 8 plus 6. At this point, you're using order of operations. If you cannot use order of operations, please just put it in your calculator and get the right answer. Don't try to be fancy and get it wrong because you don't understand the rules of operations or you just forgot, which sometimes happens, like me. I forget sometimes. So just make sure you are following those order of operations or you're putting it into your calculator, okay? 12 minus 8 is 4 plus 6 is 10. So your solution for f plus g of 2 is 10. All right. Any questions, please ask your teacher. That is formal function notation. All right, long division. This example, long division is something you have to practice. If you still don't understand long division, please make sure you get help. All right? This is difficult. You need to make sure you understand it. Now, this is the example we are working with. Whoops. That is the example we are working with right here. If you notice, you always have to check whenever you're doing division, okay? Whenever you're doing division, whenever, you need to make sure you look out for placeholders. What does that mean? Missing terms. If you're missing terms, you need to put a 0x in there, or 0x squared, or 0x cubed. All right? It has to be missing in between your largest degree and your smallest term. Okay? So I would not add in, for this problem, a 0x to the fourth, because that's just kind of silly. We don't need to add in more. Okay? We need to fill in this plus 0x squared. That is where your placeholder is. Okay, that will tell you what you need to do. That is why we do what we do. That is how you can understand this example. Okay, if not, if you don't put it in there, you might be scratching your head for a moment trying to figure out, well, where did this plus 6x come from? x squared. Well, here we go. That's where it is. Okay. Now, as we told you, to do long division, we need to divide 3x cubed, which is your first term, your leading term, by your leading coefficient of your divisor. Okay. So 3x cubed divided by x, that equals 3x squared. So that is where I put my 3x squared, all right, above my 0x squared term. And then I took that 3x squared and we multiplied it into my divisor. Okay, we have to subtract it, so I put it in parentheses so I know to distribute that negative sign. This becomes 0, and this becomes a positive 6x. 0x squared plus a positive 6x gives you a positive 6x. Bring down my 2x and bring down my 5. Now, why did we do that? Because it will help you keep your space. You don't have to bring down the 5 all the time. You don't have to bring down this term right here, but I'm doing it just to make sure I keep on pace. Okay? And we do the same thing. We take the 6x squared. I'm going to erase this. We're going to take the 6x squared and divide it by x. This becomes 6x. So that's where it comes up here above my x term. And now we multiply that 6x into the parentheses. X minus 2, okay? So minus 6x squared minus 12x, distributed in there. This becomes a 0. This becomes a positive sign. Excuse my messy positive signs. So that becomes a negative 2x plus 12x. 10x plus 5, because we're bringing down the 5. And we do it one last time. 10x divided by x equals 10. Put that above. Multiply it into the parentheses. Subtract. Bring it down. This becomes 0. And you add plus 25. Okay? Now, look at this right here. This is your remainder. All right? The issue for my students, okay, if you're my students, listen up. What you did not do was you did not put it back into the original solution. This right here is the original solution. Right here is where you failed. You literally just didn't put that positive sign. Not all of you, but the majority of you did. Okay, so I had to take off a point for that. But here, you need to make sure whatever sign it is, whether it's a positive or a negative sign, you need to make that your operation. So plus 25 over x minus 2. And that is your example for long division. All right? Any questions, please let us know. All right. Your favorite. We just got off of using this 1,005 times when finding the roots, Unit 3, Part 1. So this should not take you very long, okay? The biggest thing that I want to talk about, I'm not going to go through the example. I'm not going to do that. I don't want to do that. I don't want to waste time. Is whenever using synthetic division, you have to make sure you understand that whatever you're dividing, you use synthetic division if your term is linear. Linear means there's no other degree except for just x to the first power. And your leading coefficient is 1. Look at this. X minus 3. Is your leading coefficient 1? Yes. Is your degree 1 for that x? Yes. So you can use synthetic division. Now, we flip the sign of that negative 3 and we change it to a positive 3. Okay? Just in case, we'll pull that 3 out. If you haven't seen it, whichever way your teacher taught you, we have multiple ways of doing this, of setting up this box. This is how I showed my students. 6, negative 19, 1, and 6. Now, I'm running out of space, so I can't be super neat about it, but I put the 3 up here. Drop your first number and then start multiplying, okay? That is how you do synthetic division. If you need help on synthetic division, I hope you do not, because I hope you know it. Inside, outside, backwards, forwards, because we've been using it for quite some time. Please see us. Please make sure we can help you get that. Whatever your misconception is, let's get it fixed. Don't wait until next semester. Don't wait until the SAT class. Please get it fixed now. All right. Let's see what's next. The end of this unit, if you recall, we had, I don't know what we missed. Maybe it was a pep rally, but we had to move composition of functions as a major quiz, and so it might not have gotten all the attention it deserves. But I have given you some really good examples of what it would look like, and one with a number, this f of g of 5 right there, and one where you're just straight doing function composition and you're writing a new rule, okay? So, if you look at these examples, all right, f of g of x, let's look at that one. I want you to pay attention to what's inside, because whatever is inside, that becomes your new x. So, this 4x minus 5 is going to be put into this whole thing, put into your x. So it'll be 3 times 4x minus 5, parentheses. Please use parentheses. If you are not using parentheses, you're going to get this wrong. Okay? 3 times 4x minus 5 plus 2. Distribute the 3. 12x minus 15 plus 2. Combine like terms, 12x minus 13. That is your new rule. Now, this is a very basic example. I did not get very technical with it. You need to make sure you understand what I just did. So please practice this and ask if you have questions. Now, another very basic example is when they give you function composition and then they give you a number they want you to follow. Okay? The first thing you're going to do is create that new rule. Since this is a very basic example, all you have to do is replace this x, okay, this little lonely x, with this 3x. So you're going to have 3x plus 2. Then take this 5 and put it in place of that x. So you'll have 3 times 5 plus 2. 15 plus 2 is 17. All right? That is the basic function composition. That's the end of Unit 2, Part 1. Any questions, please see your teacher. I'm going to stop the video, and I will start again for Unit 2, Part 2.